In this video, we'll talk about operations with rational numbers, so adding, subtracting, multiplying, and dividing with fractions. So to multiply rational numbers, this is the easiest thing we can do with two fractions. To multiply them, you just have to go straight across the top and straight across the bottom. So multiply, and then if possible, we will reduce the final answer to lowest terms. So to multiply 3/8 times 5/11, we go straight across the top. 3 times 5 is 15, and straight across the bottom, 8 times 11 is 88. So multiplying fractions is the easiest thing to do. Sometimes it's then difficult to simplify if the numbers have gotten pretty large, so you do want to be careful there in reducing. That you may need to check for a greatest common factor. If you're not sure whether they have a greatest common factor, you can quickly do the little tree and split until you get to a prime factorization. So maybe 88, 8 times 11 occurs to you. So the prime factorization for 15 is 3 times 5. Oops, I forgot to finish that one. 2 to the third times 11. They don't have any common factors, so there is no greatest common factor other than 1, and therefore it's already reduced. Next one, don't forget about signed numbers. So you have two negatives. When you multiply, that will make a positive. So 2 times 9 is going to be positive 18. 3 times 4 is positive 12. The greatest common factor between 18 and 12 is 6, so we will divide both the numerator and the denominator by 6, and that would give us 3/2. Right? So make sure that your final answer is reduced to lowest terms. And then for multiplying with mixed numbers, you're probably going to want to convert them to improper fractions first, so they look like questions A and B. So to convert to improper fractions, we remember that the whole number 3 is like 9/3, and then we have the 2/3 piece, so there are 11/3 here. And then here we have 1, which is like 4/4, plus the 1/4 piece, so 5/4. And now I can go straight across the top, straight across the bottom, and multiply to get 55/12. And that's an improper fraction. You could convert it to a mixed number, or you could leave it. And indeed, these also have no common factor other than 1, so that's already in lowest terms. For dividing rational numbers, or the quotient, you're going to want to multiply by the reciprocal of the second number. So leave the first fraction the same, change to multiplication, and flip the second fraction. That's what the reciprocal means. This is because division is the same as multiplication by the reciprocal. So let's see that in action. We have 4/5 divided by 1/10. First thing we want to do is rewrite the problem as multiplication. As long as you do the reciprocal of the second fraction, you can rewrite it as a multiplication problem. And now it's a simple process again of doing straight across the top, straight across the bottom. And then reduce your final answer. 40/5 is just 8. Just to show, this is the first time where this came up, if you recognize that the numerator of one fraction and the denominator of the other fraction could be simplified before multiplying, this might save you from having some large numbers. So I see this 10 and 5, and I know that if I really had 10 on top and 5 on bottom, that I could reduce that to 2/1. And then by doing this, I now have 4 times 2 on top and 1 times 1 on bottom, and I avoided the big number 40. So only do it if you recognize it. It's not necessary to do it that way. That's what that would be called cross-simplifying. You could just go straight across the top, straight across the bottom, and then simplify if you're comfortable with that. So here we're going to keep the negative 3/5. We're going to switch to multiplication and do the reciprocal, and then go straight across the top, right? Negative 33/35. They don't have any common factors other than 1, so that's done. And then for C, mixed numbers, again, you'll want to convert them to improper fractions first. So 4 whole circles, if they're split into fourths and all shaded in, would have 16/4 altogether, plus the 3/4. So this is 19/4. 1 and 1/2, right? That's going to be 2 halves shaded in plus an extra half, so 3 halves altogether. But now I'll want to change it to multiplication and do the reciprocal of that second fraction. So 19 times 2 is 38. 38/12. I know that can be reduced because they're both even numbers, so they can at least be divided by 2. If I do that, I will get 19/6, and that is lowest terms. So done with that one. And then we get into adding and subtracting. So for adding and subtracting, we need a common denominator between our fractions. This is what we remember as being a pain. This is why we think of fractions as hard. So here we have 2/7 and 3/7 being added together. They're both over 7 already. So we just add the two numerators together and leave the denominator the same. This works as long as the denominator is the same. The reason being, if you have one circle divided into 7ths, ugh, that's an annoying one. I'm not going to be too good at dividing this into 7ths. 1, 2, 3, 4, 5, 6, 7. They're not equal. They're supposed to be. The point being, if I have one circle divided into 7ths, I can shade in two pieces, or three pieces, right? Because this question started with 3/7. Shade in my 3/7, and then I'm adding two more 7ths to it. So I don't need a different circle with a different drawing. I can just keep shading in on the same circle because they're already 7ths, right? So then in the end, I have 5/7. And then when we have one with different denominators on the next slide, I'll show you the difference there. 11/12 minus 5/12, we go straight across the top to subtract. There would be 6/12 left over. And then don't forget to reduce your fraction. If you can, reduce it to lowest terms. And then similarly with mixed numbers, we want them to be, probably want them to be improper fractions first. It's just going to make your life a little bit easier. These are both negative. So if I convert this to an improper fraction, and I convert this to an improper fraction, remember that a subtraction of a negative is like adding. It's not that the first number, the negative 21/4, is still negative. It's that the subtraction of a negative 11/4 has become the addition of 11/4. And so for this, I will do negative 21 plus 11. That gets me closer to 0. So I'm at negative 10/4, and then I would reduce to lowest terms if I can. So if they don't have the same denominator, what are we going to do? So if they don't have the same denominator, the problem being this circle is divided into 4ths, but this circle is divided into 6ths, right? There's 6ths pretty easily. And so I can't just have 3 pieces shaded and then shade one more, because if I shade 3 pieces of the first circle, that's 3/4, and I can't just shade in one more piece because the piece that's left in this circle to be shaded is not a 6th, it's a 4th. So I would have to go to a completely different circle and add in this 1/6. So what we want to do to add these two circles together, or to add these two fractions together, is find a common denominator that we can split the circle into that many pieces, and then imagine that we're shading in whatever the new numerators are. So the common denominator for 4 and 6, we're going to be looking for the least common multiple. If you remember the procedure for that, it's to do the prime factorization. So this is 2 to the 2nd power. This is 2 times 3. And we're going to take everything that they have. If there's a number that shows up more than once, we're going to just record it the fewest number. I think, oh no, the most number of times that we see it. Right, that was the procedure. So here we're going to take a 2. The most number of times that we see that appear in either prime factorization is 2, so the 2 squared. And then 3 we have, the most number of times we see that appear is 3, just one time, so we put it there. If we multiply these out, this is going to be 4 times 3, which is 12. That's the least common multiple. That's going to be our common denominator. So if I want the denominators to be 12, what I've had to do to get there is multiply this by 2, so I do the same thing to the numerator. What I've had to do here is multiply this by 3, so I do the same thing to the numerator. And now I have equivalent fractions to what I started with, but both in terms of a denominator of 12. So now I could have one circle split into 12 pieces, shade 9, shade 2, and in the end I would have 11 pieces shaded out of the 12 pieces in my circle. So common denominator is quite a bit more work than multiplying and dividing or adding with same denominators. So we'll just do probably one of these in the interest of the video not getting too long, but certainly continue to practice. The hardest one here is B, so let's do that one. 15 and 24. Trying to find a common denominator for those is a chore. So I am going to want to do the prime factorization. This time I'll try not to mess it up. So 15 splits into 3 and 5. That's the prime factorization of 15. 24, maybe you think of 2 and 12, and then that's 2 and 6, and that's 2 and 3. So 24 prime factorization is 2 to the 3rd times 3. So I'm going to pull out every number I see, the most number of times I see it. I see the number 3, the most number of times I see it is 1. In each factorization, it only appears one time. I see the number 5, it only appears one time. I see the number 2, it appears 3 times. And so if I then take out a calculator to figure out what 3 times 5 times 2 to the third power is, I'll realize that it's a large number, 360. So the common denominator here has to be a 360. So I rewrite my problem with 360 in the denominator, then I need to figure out how do I modify each of my original fractions to get 360 as the denominator. So in order to get 15 to become 360, the first fraction, I actually had to multiply it by 24. And so the numerator is going to be 1 times 24. In order to get 24 to become 360, multiply it by 15. And so the numerator is going to become 7 times 15, which I believe is 105. And then I have to do the problem 24 minus 105, which is pretty ugly in itself. And that's going to be negative 81 over 360. And then this can probably be reduced to lowest terms. So here's where you would then want to do a factor tree for 81 and a factor tree for 360 and find their greatest common factor, divide by it, and then reduce this fraction. So in the interest of time, I won't do that. Or you could also probably put that into a calculator, and it might help you reduce that fraction as well. And that is all.